compounds, and we start our discussion taking up carbon. Carbon, denoted by the symbol C, C6, carbon 6. That means its atomic number is 6. That means the configuration is 2,4. So it has got 4 electrons in the outer orbit. Available in 3 different isotopes, carbon 12, carbon 11 and carbon 14. We will be studying more on carbon 12. This is what we will be studying. Carbon 6, carbon 12, carbon 14, 11, 12, 14. Okay. Electronic configuration is 4. So from now onwards, have the habit of making structural formulas. Molecular formulas have no role in organic compound. No role. So this is how carbon is shown. These means there are 4 open valencies. It is in hunt of 4 electrons. Okay. So those 4 electrons can be filled up. Say for example, I have a carbon atom, and how many electrons I have? I have got 4 electrons. Right? You are familiar with little bit of bonding. There is one bond called electrovalent bond or ionic bond, in which the electrons are transferred directly. There is another bond called covalent bond, in which the electrons are shared. And there is one more bond called coordinate valent bond, in which only one person donates it. Leja. The other person does not do anything. We are going to discuss in this chapter, everything will be covalent bond. So let's first understand what is a covalent bond. So I have got another fellow whose name is, say, hydrogen. So hydrogen comes here with 1 electron. There is another hydrogen which has come with 1 electron. There is another hydrogen which has come with 1 electron. There is another hydrogen which has come with 1 electron. Sharing means, now if you go by the valency rule, a person can either gain 3 or lose 3. Beyond 3 is not possible. Beyond 3 only sharing happens. Now here the demand is for 4. Hydrogen needs 1 to complete its duplet. This fellow needs 4 to complete octet. So there is a sharing bond formed between them. Sharing. Now if I count for this hydrogen, I will count both. And if I count for this carbon, 1, 2, 3, 4 white dots, 5, 6, 7, 8. Methane. This is methane, which is the major ingredient of natural gas, organic compound. So have you got an idea about what is covalent bond? So carbon has got a valency of 4. Now this valency of 4 can be satisfied by any one person with whom the match and the deal can work. Let's say we take chlorine. Chlorine is how many? What is the electronic configuration of chlorine? 287. So it needs 1 more electron, right? 287. Chlorine is 17. It needs 1 more electron. So it pairs with carbon, forms a compound called CCl4, carbon tetrachloride, organic compound again. Have you understood? Now let's see it in a more interesting manner. Now we take our discussion and we say that this is carbon. Why are you combining it with chlorine and hydrogen? Let's see a beauty. Why can it not combine with carbon also? Yes, it can. Do you see this? All possible. Are you seeing a wonderful thing happening up? It's like a jigsaw puzzle. Sir, how much can you make? As long as you want. As long as you want. Sir, let's make a compound. Let's make a compound. So interesting. We made a compound with 1 carbon plugging with hydrogen. Sir, let's change the compound. Let's take 2 carbons. Are you able to decode this? This is a bond between a carbon-carbon. And sir, let's, like this one, plug rest with hydrogen. Possible? Possible. We make a compound C2H6, which is known as ethane, major component of LPG. Possible. Then somebody says, sir, no, I want to make 3 compound. I said, make 3 compound, whatever you want. Your wish. It becomes propane. Slowly you will understand. So one thing that we see, that in the case of carbon, there is a unique something, that a carbon can combine with a carbon and form endless chains. However, the policy is, are these chains stable? They have to be stable also. The unique property in carbon is that they are highly stable. But if you see the element just below carbon, that element's name is silicon. So silicon should also have 4 electrons in its outermost orbit. Silicon should also show this property, doesn't show. Silicon structures are not stable, which makes the world so unique that there is only one element which can combine with itself and form large chains, and all chains are possible. So as a chemist, it's very interesting for me. I can make as many types. This compound will behave different from this. This will behave different from this. Oh, I have got a world of things that I can make with carbon. It's like a jigsaw puzzle or a Lego toy, as many shapes as you can give it. So here we use two words. We say the word that carbon has a valency of 4. So the word we use is called tetravalent. Carbon is tetravalent. And we use another word called catenation. Catenation. So let's understand what is tetravalent. Tetravalent means when your valency is 4, we call it tetravalent. Silicon is also tetravalent. Catenation is the phenomenon by which an atom can link with itself and form large chains of stable compounds. Silicon does not exhibit catenation. Why? Valency satisfy kar raha na arithmetic. Silicon structure is like that. It becomes heavier. Carbon is unique. That's why we say organic chemistry is all about carbon, because in inorganic chemistry you have finite number of compounds, not infinite. But in organic chemistry, what is the count of compounds? Infinite. कल कुछ नया चाहिए, नया बना देंगे आपको. The menu card is unlimited. And why is it infinite? Because of this property called catenation. So remember two things. One is called tetravalent. Carbon is tetravalent, and carbon shows catenation. What do you understand by catenation? Catenation is a phenomenon due to which an atom of an element can combine with itself and form large chains of stable compounds. Carbon shows the property of catenation. Catenation in Seedha language is something like self-combination. I don't need anybody else. I play with myself. मुझे कोई दोस्त की जरूरत नहीं है. मैं अपने घर में ही खेल लेता हूँ. यहाँ तक क्लियर हुआ? And these are not only what you call stable, these are strong bonds also, strong and stable. So the existence of such compounds is not arbitrary or theoretical or hypothetical. In reality, they do exist. आप चाहो तो आप बना सकते हो. Okay. Now let's see what is the occurrence of carbon in nature. We have still not entered inside organic chemistry. Yeah? We're just understanding carbon. Occurrence. In occurrence, we have got two things. One is called combined state. Combined state like calcium carbonate, carbon dioxide. These are carbon in combined state. Another is called free state. Free state. When a substance occurs in more than one form, then that phenomenon is known as allotropy. मजा लो अभी साइंस का. Allotropy. Allotropy. Like in Hindu mythology, God is seen in different faces. You know what is it known as? Anthropomorphism. This is allotropy. Allotropy means a same element occurring in different forms, and the forms will be known as allotropes. The forms will be known as allotropes. Clear? Basic clear कीजिए. So carbon in free form, free state, it will occur in the form of allotropes. And the phenomenon due to which somebody occurs in two or more different forms is called allotropy. We generally say carbon occurs in graphite and diamond. ऐसा नहीं है. These allotropes can again of two different types: amorphous and crystalline. Amorphous means when the structure is not, the pattern is not regular. What are amorphous form? Coal, coke, grade 8, coal, coke. Those are amorphous forms. But in grade 10, we will be studying the crystalline form. Crystalline is like defined. Diamond and graphite. If you see this much of diamond, you can predict how this much of diamond will be. But if you see this much of coal, you can't predict what is the structure. Coal is amorphous. Diamond is crystalline. So we see only the crystalline forms, and the two crystalline forms are known as diamond and graphite. अनुराग रिवीजन हो जाएगा तुम्हारे यहाँ पे पाई बॉन्ड फिर से. Graphite and diamond. So let's again understand. Carbon occurs naturally in two forms. Free, combined. This is not our headache. Free state, if it occurs in more than one or two different forms, it is known as allotropy. And the states forms are known as allotropes. So this is an allotrope, this is an allotrope. Coal is also an allotrope, but coal is the amorphous allotrope. This is the crystalline allotrope. Is this much understood? Okay. So let's go to diamond. All of you know about diamond. Ladies and girls never like this substance. They are the enemy of a girl. So that is diamond. Diamond has got a tetrahedral structure. Tetrahedral. Tetra stands for 4. Hedral obviously for heads. How many heads? 4 different heads. 4 different heads. So it's typically like this. A carbon, and one is shown like this, which is at the back side. Each carbon has to be linked with 4 carbons. So this is the tetrahedral structure of diamond. This is the tetrahedral structure. You take 4 carbons, very easy to make. Take one tennis ball and put 4 fangs in it. One fang on top, one on this side, one on this side. So it is like, now it is like a 2-legged tripod. Make it a two-leg bipod. Then make it a tripod. 1 carbon, 2 carbon, 3 carbon, 4 carbon, and this is the center carbon. Link all with straws. And on every triangular face, you put a triangle papers. Then how many faces you are getting? 4 faces. Able to visualize or not? Take any tripod. Take the tripod of a camera. And on that, every face you start fixing. So this is called a tetrahedral structure. Diamond is tetrahedral. Diamond is a very good conductor of heat. Diamond is a poor conductor of electricity. Right? Because diamond does not have any free electrons. All the electrons are paired. As I told you, metals will have 2 types of electrons, bonded electrons and free electrons. It had 4 free electrons, the valence electrons, the chapris. They got paired with similar chapris. And that pairing, that electron-electron pairing is happening on a head-on pairing. So in higher classes, we call this as a sigma bond. This is the symbol for sigma, smaller sigma. This is the symbol for capital sigma. This is small. This is a sigma bond. It's a strong bond. And this bond is happening by head-on pairing of the 2 orbitals. This is the structure of diamond. Diamond will be a very good conductor of heat. And if I burn diamond, that is at 3000 degrees Celsius, all I'll get is carbon dioxide. Okay? And you know, the diamond shows total internal reflection. The critical angle of diamond is less than 24 degrees. As such, any ray which originates inside diamond is unable to get out. It undergoes what is called total internal reflection and gives you that dazzling display. Is this understood? Let's once again look at graphite now. The other form is known as graphite. Graphite is a hexagonal structure. Each carbon linked to 3 carbons on a layer. On a layer, this is very important. On a layer, okay, each carbon is linked to 3 carbons on a horizontal layer. Then your understanding will become clear. On a horizontal layer. Acha, tell me, how many valence electrons does carbon have? Carbon has 4 valence electrons, that is 4 chapris. So we are saying each carbon is linked with 3 other carbon atoms. That means if I was a carbon, I've got 4 chapris around me. 3 chapris pair with 3 chapris. What about the fourth chapri? That is all the story about. So let's see. So you have a structure like this. This is the structure of graphite. Like, let's say this is the structure. So I've got carbon, 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 carbon. I'm saying the carbon just like that. No, this belongs to my mom, my mom, 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 mom. I'm saying carbon like that. You know that mom, mom, mom? This is mom, 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 mom. Met Gala show. So look at, take up any carbon of your choice. This is one carbon. And if you see, this carbon is linked with 3 carbons, as we were saying. Every carbon is linked with 3 carbon. So you might say, sir, this carbon is linked with only to array, Dhakkan. There will be another hexagon here also. Clear? As I said, on a horizontal layer, the graphite is layer type of substance. Okay, there's a horizontal layer. Remember, we have got one more additional electron which we have to still show. So what I do, I will actually clone this up. Okay, so let me clone this, and if I clone, I get another layer. I get another layer. Have you understood? Exact layer below it. Now let's pick up one atom of our choice. Let's pick, say, this particular atom. Let's pick this atom. Its corresponding atom will be this atom, right? Both of them have got one electron free. That free electron makes a weak bond on a sidewise overlap. So imagine my thumb as one carbon, graphite layer, and there is another graphite layer. So the two thumbs, this thumb has got a free electron, this thumb has a free electron. They also make a bonding between them. But this bonding is not head-on. This is a sidewise overlap. This bond is known as a pi bond. This is known as a pi bond. Pi bond is weaker as compared to sigma bond. Sigma bonds are very strong, but pi bonds are weaker. However, they are bonded. So similarly, this particular carbon will be bonded with this carbon. Do you agree or not? So all these fourth chapris bond with the respective fourth chapris and make a chapri mayonnaise. And that's just a chapri mayonnaise made now. They are what I used to say, sea of electrons, cloud of electrons, delocalized electrons. So they make a chapri layer, which is like a mayonnaise. So layer 1 is happily able to slide over layer 2, which is the main property of graphite being used as a lubricant. Graphite powder is an excellent lubricant. If you can crush down your entire pencil lead and your hands will become dirty, if you have used, like, say 4B pencils, sketching pencils. 4B is a very soft pencil, costly. And if your bathroom door is making noise, you can always make your parents angry by saying that I'm studying science. Take your 4B pencil and shade the hinge of your bathroom door. The entire 4B pencil will be worn out, but the bathroom door will become so smooth. Aha. Because you have introduced graphite into it. Got it? And what is the job of a lubricant? The job of a good lubricant like grease and all is to absorb all the heat yet not melt. Grease is a very stylish product. Grease is put on wearing and tearing parts. So wearing tearing parts will do what? Heat up हो जाएगा. लेकिन grease खुद melt नहीं होता है. See, you can actually, what grease does, the same thing your Vaseline which you put on your skin will also do. But the Vaseline can solve your door problem, but not the engine lubrication problem or the bearing or the steering joint problem of your car, because that gets heated. There, if you put Vaseline, entire Vaseline will become liquid, but grease will stay like grease, jelly, yet not melt. Okay? So this is the structure. Graphite conducts electricity. Graphite conducts electricity because graphite has got free electrons. Many children think that in graphite, how is the bond? Each carbon is linked to 3 other carbon on the same layer, and between 2 layers, the delocalized electrons pair up. So ultimately, it's a 4 bond. Structure to stable hona padega. So this is good conductor of heat and a good conductor of electricity, an excellent conductor of electricity. Which one? There, this bond is not strong, as I told you. This bond is a weak bond. This bond is so weak that it will keep the layer, but this electron is not paired. Otherwise, it won't allow you to. Diamond is very hard. Do you know? Diamond is used for cutting. Diamond is the hardest substance. If you could make a diamond ball and put it in a catapult and hit it on Vakul's head, he can kiss his skull goodbye. It will hit here and get out from here. Diamond is very, very hard. Graphite is not hard. Bonding strong nahi hai. So that electron is almost considered to be free. It is like the wheelchair of your tower. Does it remain in the tower? Yes, it remains in the tower. Does it remain to any flat? No. It's delocalized. Okay. So is graphite and diamond clear? So there is one more form which was a recent invention. When we used to study in grade 10, we never heard it. It's called Buckminster fullerene. So Buckminster fullerene is nowadays graphite is the nanotechnology. When they say all your cell phones, the screen that you have, ऐसे ऐसे करते हो ना, reel देखते हो, that is a substance called graphene. And have you seen sci-fi type of movies where they'll say, I just say the intruder, well, it says porn, something on glass or vacuum, they will plot everything. That is entire nanotechnology. That's possible actually. That is possible. And all these things come up from graphite. The mobile screen, it is a touch sensitive screen, which it should conduct. If you wear gloves and do like this, it will never work. Have you seen that? And the screen guard protector that you put, you think it's a piece of glass. No, it's not a piece of glass. If you put a piece of glass on your mobile phone, then you should not be able to toggle the screen of your mobile phone, but you're able to toggle. So what is that technology? That is also some sort of graphene. So another is Buckminster fullerene. I mean, just for knowledge, they don't ask questions from this. Okay. This actually takes us and makes us understand the concept of, we are now ready to get into the concept of organic chemistry. So at this stage, what did we study? We just studied that what is so unique in carbon. The most unique thing in carbon is that it has got a valency of 4, it's tetravalent. It has the property of self combination, which is called catenation, can form large chain of compounds which are stable as well as which are strong. Such phenomenon is not exhibited by silicon also. Then on forms of carbon, little bit about graphite and diamond. So if I start today the first topic, I'll not be able to finish, and I don't want to do anything halfway. So in our next class, what we will do, we'll get inside organic chemistry, and preferably if you are studying organic chemistry, keep some white pages so that from now on itself you can keep some preliminary notes, which will be helpful maybe in this class or maybe in your next class. I will try my best so that you start loving it. It's not that difficult. And you have to love it, at least for 11, if you're studying chemistry. What you're studying as one chapter, the whole of class 12, one book is organic chemistry. 2 books are all organic chemistry. So, रुलाएगा थोड़ा सा. But we can help it. ठीक है? Any doubts or anything, keep posting. Our next class, so we are starting 2 new phases. One is current electricity. So the fairy tale part of current electricity is over. Conductors, insulators, we have spoken. So we dive deep into the subject from next class, and so is for this one also. ठीक है बच्चा?